Hello everyone, and welcome back to the second part of test 4 of right triangle trigonometry. So if you're asking me why not just combine all the problems in one test, that will be much better. Yeah, but I am worried about number one, the attention span of the viewers. All right, so the longer, and I think the worse it will be in terms of the views. All right, so sometimes I should be giving longer videos, but uh at the same time, for other videos, I have to make it as short as possible. Like, for example, maybe less than 20 minutes or less than 25 minutes or less than 30 minutes. That would be much better. All right. So without further ado, let's now begin. All right. So here, this is actually the last problem of test 4. We will find all the 6 trigonometric ratios in a given right triangles based from a given acute angles A and C. Basically, in other words, we will find uh, all trigonometric ratios at angle A and at angle C. But before we will find the angle, we need to find the missing side here. We need to find this one. We need to do that. Because again, all right, you cannot find the equivalent ratio of other trigonometric functions if we have a missing side. So we will do Pythagorean theorem. And remember the last time we did when we find Pythagorean theorem, right? We find first uh the the parts of the sides, right? Hypotenuse, opposite, and adjacent. But you know, it's hard for you to, or rather inconvenient for you to know which one is your opposite and which one is your adjacent because you have two given acute angles. So for the sake of making it convenient, let's label these parts as A, B, and C. Okay? Let's label them. All right? Because our goal here is to find what? To find the missing side without the use of angles. All right? So in here, we can apply Pythagorean theorem. So we will have a squared plus b squared is equal to c squared. That's it. So now what we're going to do is we will find the a for us to find the measurement of line segment AB. All right? So we have a squared plus your b squared is simply the square of, why do I keep writing this 1000, whatever. Hi, 1719 kilometers squared is equal to, for your c, which is uh, the square of 2350 kilometers. All right? So I assume that if you're going to get the square here, it will reach into million places. So I think it's better if I'm just gonna keep it like this and let a calculator do the work. All right, so I'm just gonna put this on the other side. We will have a squared is equal to the square of 350 kilometers minus 1719 kilometers squared. All right, so we will square root both sides for us to find our a. So as a result, we will have the square root of the square of 2350 kilometers minus the square of 1719 kilometers squared. And now let's use our calculator. Or if you're good in not using calculator, then so be it, right? So we have 2350 squared, then minus 1719 squared. So here we will have approximately, just like what I said earlier, or I'm sorry, from the last video, um, if you think the answer has like multiple number of decimal values, I think it's better to stop at least at 2 decimal places. So for me, I'm going to stop at 2 decimal places. So I decided to have 1602.35 kilometers as our missing side. So that is the missing side here, right? So let me just put a label here. So this is 1,602.35 kilometers. Okay, so we're good to go. All right. So we already have all measurements for each side. Now what we're going to do now is we will find all the six trigonometric ratios. All right. First, let me copy this. All right. This is the last time we solve, right? Solve the, what's that? The given right triangle, right? So let's use this one instead of just rewriting everything. Rewriting everything, or what I mean is that we're going to rewrite again all the formula. That would be a waste of time. So these are now the six trigonometric ratios. All right. So in here we have given acute angles A and C. Sorry, A and C. So what does that mean? Meaning we're going to find all the trigonometric ratios at angle A at angle C. All right. So let's start first with at angle A. Okay, let's start first with that. So what happens if we base the angle at angle A? So here, imagine this, okay? Just imagine. Imagine that there's no angle here at angle C. Because recall that if there's an angle here, okay, angle here at the vertex, and that vertex has a name, which is C, we name it as angle C. All right? And likewise for this case, if we have an angle at the vertex of A, we call it angle A. All right. So now going back, imagine there's no angle C here. We have only angle A. So if we have angle A as our given acute angle or the angle that we're referring to, then what would be its trigonometric ratios? So before that, we must know what are the hypotenuse, the opposite, and the adjacent. That's the first thing that you must do before we will substitute. So, of course, the hypotenuse is the longest side, which is this one. Now, since the angle is beside the vertical side of the right triangle, or the height of the right triangle rather, so this is your adjacent. Okay, your adjacent is 1,602. Then for this case, the one that is not beside to the angle, that is your opposite. All right? So, therefore, we can simply now substitute these in these given trigonometric ratios. All right? Now, sine theta is equal to opposite all over hypotenuse. So that means we will have opposite 1,719 all over your hypotenuse 2,350. Okay? Now, for your cosine theta, we have adjacent all over hypotenuse. So this is 1,602.35 all over the hypotenuse 2,350. Wait, let me take a look if I can simplify that. By this 1,600.35 divided by 2,350. Okay, there is a simplified form, but it looks different though. Okay, I'll show you. Wait. I'm using a calculator, by the way. Okay, if you're wondering how I got the simplified answer. This one, according to my calculator, it's 32,047 all over your hypotenuse, which is 47,000. So you see, it's quite different. Actually, it is very, very different, but they're the same. They're just the same actually. All right. So if you think according to your calculator, this is a simplified answer, sure, there's no problem. All right. As long as it is correct. Now let's proceed. For tangent theta, we have opposite of 1,719 all over your adjacent, which is 1,602.35. Now, I want also to make sure if this can be simplified. 1,719, 1,602.35. So here, we also have its equivalent fraction according here, that this is the same as 34,380 all over 32,047. Okay. So yeah, whether this one or this one, both of them are correct. All right? So that's it. Now let's find cosecant theta, hypotenuse all over opposites. So again, if ever, you're tired of substituting, just like what I said on the last video, cosecant theta is the reciprocal of sine theta. Basically, the exchange position of the ratio. So if we have 17k all over 23k for sine theta, for cosecant theta, that would be 2,350 all over 1,719. Okay? Second theta, all right? Similarly on what I did to cosecant theta, secant theta is just the reciprocal of cosine theta. So for cosine theta, if we have 16k all over 23k, then here we will have 2,350 all over 1,602.35, or we can simply rewrite this as 47,000 all over 32,047, right? And lastly, for cotangent theta, this one, just as like what I did to secant theta and cosecant theta, cotangent theta is reciprocal to, wait, sorry. Cotangent theta is reciprocal of tangent theta. So if we have 17k all over 16k, then that means we have 1,602.35 all over 1,719. Or we can simply rewrite this as 32,047 all over 34,380. And these are your trigonometric ratios at angle A. Okay, at angle A. Okay? So we're good to go, but we're not done. Okay, we're not done yet. Okay? We're not done yet because we finished at angle A. But how about at angle C? Okay? How about at angle C? Wait, I can't copy this. Wait, for a moment. All right? Now, how about at angle C? Okay? So, let me go back drawing the angle here. All right? That's it. Now, how about at angle C? Let me use different color. All right, at angle C. Now, if it's angle C, then you imagine that there's no angle A existing. Imagine there's no angle A existing. The only existing is we have a given acute angle at C, which is angle C in other words. Now, if that's the case, then what would be the sides of your right triangle here? Like which one is hypotenuse, opposite, so on and so forth. So the hypotenuse does not change. Again, hypotenuse is the longest side of the right triangle. So, which is 2,350. This is your hypotenuse. Okay? Now, on the legs, for the legs, however, there is a change for that. You see, the angle is beside the base, which is BC, line segment BC. So, therefore, your adjacent is, oh, wait, no. Wait. Therefore, your adjacent is BC or 1,719. Then, on the other hand, this one, okay, this AB, which is 1,602.35 kilometers, that is your opposite. Okay? That is your opposite. And then the base, that's your adjacent. And that's it. Right? So now that we know our opposite and adjacent, so we can now find the six trigonometric ratios. So let me just copy this one. Okay. All right. Let's just copy this one. Then you're just gonna erase our previous answers. All right. Give me a second, guys. Let me just erase this. There we go. And there we go. Okay. So at angle C, let's find the trigonometric ratios. Okay, so for our opposite, we have 1602.35 all over the hypotenuse, which is 2350 kilometers. That's it. So that's our sign. Let's take a look if we can simplify this. I think there's a simplified from this one, right? 1/6 all over 235. Yeah, there we go. So we can simply rewrite this as 32,047 all over 47,000. Am I right? Let me take a look. Okay, good, good, good. That's it. That's for the sine theta. Now for cosine theta, we have adjacent all over hypotenuse, so 1,719 all over 2,350. And that's it. For tangent theta, we have opposite all over adjacent, which is 1,602.35 all over 1,719, which is, I think there's a simplified for this one. I do believe so, which is, uh, yeah, 32,047 all over, wait, all right, good, good. All over, what's this? I think that's, wait, 1,700. Okay, thank you. 34,380. Let me double check. Okay, good. Now, for cosecant theta, we have adjacent hypotenuse all over opposite. So this is just 2,350 all over 1,602.35. So this is 447,400 all over 32,047. Now for second theta, so this is 2,350 all over 1,719. And lastly, for cotangent theta, so here we will have 1,719 all over 1,602.35, which is, in other words, 32,047 all over 34,000. Wait, no, 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 no. No, no, no. Sorry, sorry, sorry. I was wrong. Forgive me. I was wrong. Uh, Going back. So this is, once again, 34,380 all over 32,047. All right, let me double check if I'm correct. Okay. All right, all right. Okay, good. So we're all done now. So these are your six trigonometric ratios at angle C. So let me go back again at my drawing here. All right. So these are like your answers for angle, uh, yeah, at angle C. Let me just drag this one. All right. Let me just wait. There we go. All right. So now we have the answers at angle A and angle C. All right. There we go. All right. There we go. That's it, guys. So we're done now in test four. And I hope to see you at the uh last part of our test for right triangle trigonometry. All right? So see you soon.